Hello, my name is Dervla Frumming with MIPI Alliance. Today's webinar is presented by Sakari Ailus with Intel Corporation. Sakari is also a member of the MIPI Camera Working Group. A few things to note before we start the webinar. The presentation slides and playback will be available on demand approximately 2 hours after the end time of this webinar. The slides are also available in the Knowledge Library at mipi.org. The presentation is approximately 20 minutes, followed by a short demonstration, and then we'll open up for a Q&A session. Currently, you're viewing the webinar console. You can minimize and maximize each of the panels by simply clicking one time. I encourage you to raise your questions directly in the Q&A panel. With that, I would like to introduce Peter Lefkin, Managing Director with MIPI Alliance.
Today we have an interesting webinar today, and thank you for joining. We have a presentation from Sakari Ailus and presentation of MIPI CCS Tools and demonstration as well. And so what I'll do is just give a little bit of an overview, very brief, on about the MIPI Alliance and some of the history as well as some of the current activities. With that, MIPI Alliance was formed in 2003 really to integrate at the time when integration of cameras were moving into mobile phones. And our reason for being was really the development of the camera serial interface, CSI, which, you know, Sakari, fast forward 17 years, will be further presenting, some development tools that we've implemented this year for that. But we also, not only camera, we worked on display as well since 2003. And if you fast forward to today, we are looking at a set of specifications where at least one MIPI specification is in every mobile device on the market today. Our ecosystem has expanded beyond the initial founders of the application processor developers, the device OEMs, and the semiconductor companies. Now that the MIPI specifications are mature and widely adopted in the marketplace, we have test equipment companies, the test labs, the software providers, IP and VIP providers, consumer electronics companies from all different kinds, as well as automotive OEMs and tier one suppliers as well. We have over 350 members in over 29 countries. This slide of board and contributor members is really representative of the board and contributor members who are developing the specifications and part of the working groups on a day-to-day basis. There's another list of members called adopter members who gain access to the published specifications once they're made available to the adopter members and are published and adopted by the MIPI board. That list of companies couldn't necessarily fit on one slide. It's about 3 times as many adopter members as we have board and contributor members. MIPI specifications really run on the left side of this diagram. You see the mobile system diagram that really portrays the MIPI specifications within a mobile system. And, as we've indicated, and as I'm sure you may be aware as well, is that MIPI specifications go well beyond mobile. As mobile has evolved over the past 17, 18 years, we find MIPI specifications in automotive for a long time, actually, since 2010. Industrial, heads-up displays, and consumer electronics and avionics, medical device industry, as well as the IoT applications. And so as mobile has evolved, so have MIPI specifications. And now the specifications are available for implementation by MIPI members on a royalty-free basis, irrespective of the application area. And that has evolved over the years, as recently as early 2019, when we enabled royalty-free implementation across any application area. With that, I'd like to hand it off to Sakari, but I want to make one specific comment, and then we'll move into the heart of the webinar today, which is, MIPI specifications. MIPI is about developing specifications, but it's also about supporting the developer community and MIPI members and users of MIPI specifications who implement products based on MIPI specifications. And so here's a great example of a set of software and tools that have been developed, under the umbrella of MIPI Alliance, led by a group and working with the Camera Working Group. And so with that, I'd like to hand it off to Sakari for the rest of the webinar today. Thank you, Sakari.
Thank you, Peter. Hello, everyone. My name is Sakari Ailus, and today I'm going to talk to you about CCS and CCS tools. And I'll begin with a short introduction to CCS, a very short one. CCS standardizes the control interface of raw camera sensors. And besides the control interface, it includes capability and limit enumeration. And this mechanism allows basically easily implementing low-end and high-end devices, of course, mid-range as well, using CCS. So if you only have a device with very limited set of capabilities, the interface remains quite slim, but also features that are required by high-end devices are there as well, such as PDAF. And as a low-level interface where the functionalities of the sensor are orthogonal, it is very flexible and extensible. And perhaps most importantly, at least from my point of view, this allows developing a generic driver for all CCS compliant devices. This has the benefit that there is no need to write more camera sensor drivers. A single CCS driver is enough because it can control all compliant devices. And there is also no need to maintain these drivers that do not need to be written. The maintenance point will grow in importance in the future because of the security, both because of the need for security updates and the longer software support time spans. About limits and capabilities. Traditionally, the limits and capabilities in CCS 1.0 have been located in sensors hardware registers. Some of these values may be only available at late phase of sensor development. Sometimes these values also need to be updated once the hardware is already out there. And also, some of this information has no good fit to be conveyed using a register interface. And additionally, there are also manufacturer-specific registers that in the past have been part of software drivers. These are basically register address value pairs that you don't need to know what they're about, but you need to write them to sensor registers after powering the sensor on for the sensor to work. And what new does the CCS 1.1 and CCS Static Data bring here? Is basically CCS Static Data addresses this problem by moving this limit and capability information out of the sensor's register address space. Defines a block-based format that includes support for including but not limited to read-only registers. This is basically limits and capabilities. Manufacturer-specific registers. These are registers that and values that the software needs to write to the sensor registers after powering the sensor on. Frame format descriptor. So it basically describes the format of the frame that the sensor sends over the CSI2 bus. And there is support for conditional functionality based on standard sensor registers as well. So for instance, if you have a dependency from a standard sensor register to a manufacturer-specific register, it can be implemented using this. And CCS static data remains extensible if there is need for future new functionality in the future. It can be done. But this is an interesting slide. I'm always very happy to show this. That makes the next problem very easy to understand. This is a hexadecimal dump of a valid CCS static data file that describes various properties of a sensor. And as such, I would say that it is not very easy or even feasible to try to edit this by hand. And here is where CCS Tools comes to help. CCS Tools is basically software that helps you working with CCS static data binary format. First, it defines a new YAML-based format, which is human editable, but can express the same information that CCS static data binary format as well. And there is a CCS static data YAML to binary format converter, so that once you have written this CCS static data in YAML, because it can be written by humans, and then you can convert it to a binary using that converter. And finally, we have CCS Static Data Parser Library. And all this is licensed under the 3-clause BSD license. A few words about the CCS Static Data YAML format. As I mentioned, this is human editable, human readable, but it also can be easily generated by other programs because it is conforming to YAML. And functionality is equivalent to the CCS static data binary format. Here is an example of the YAML format. This is not exactly the same information that was in the binary a few slides back, but here you can see we have a data version block and the version major and minor numbers and the date, and then sensor read-only register block, which is basically containing limit and capability information. So this is the view to the CCS static data when you use the YAML format. A few more words about the library. Basically, you give the library interface function, the CCS static data binary, and it will parse it into a C data structure that can be easily used by programs, C programs. It's basically one of the benefits of this is that it facilitates driver implementation. Different drivers and different operating systems do not need to implement this same functionality over and over again, but they can use the same parser library, and hopefully would do that as well. Because the common implementation avoids implementing and maintaining new parsers for the same format, and if there are bugs, we would know about the bugs. So we do not need to try to adapt to bugs present in different implementations. Here are a few resources related to CCS and CCS tools. The specification can be downloaded. CCS specification can be downloaded from here, and there is so a MIPI software project page for CCS tools and GitHub repository link as well. And next, we are moving to the demo. Let's wait a bit for it to become visible. It should be there now. So what I have here is an SSH connection to a system that has a CSI2 receiver and a camera sensor, which is being controlled by the Linux CCS driver. First, I'm going to use a test program to display what kind of devices there are in the system. Here's a view of the test program. On the test program to the CCS compliant sensor, we have one V4L2 subdevice representing the CCS camera sensor's pixel array. There is another one for binner and the scaler finally. Let's say that if we wanted to change, for instance, the analog gain limit for this sensor, which I understand might be an entirely realistic use case for in real world, how would we do that? Let's see what the limits currently are. So this is the device node that this pixel array can be accessed. This is where the analog gain control would be. So let's try that. See, and there are quite a few controls. Let's try to find the right one. There's exposure, flip, analog gain constants. But where is the analog gain? Did I miss it? Ah, there. There's the analog gain. The minimum value for it is 0 and the maximum is 900 with step of 1. So I have here on my home directory clone of the CCS Tools Directory. I could actually show you a little bit first what there is. We have CCS data. These are part of the CCS static data binary format parser, and we have this CCS reg.asc. This is the register definition, but this is CCS static data YAML format.txt is the description of the YAML format of the CCS static data, and CCS YAML to bin. This is the YAML to binary converter. And I have created here an additional file called sensor.yaml. It's quite a big one actually. Let's see what's in there. First we have the data version block. It's similar to what we saw in the presentation, and some read-only registers as well. And then we have sensor manufacturer reg block that continues well beyond the lower edge of this window. Here we see the align in the sensor read-only reg section that says analog gain code max. This is the name of the limit corresponding to the analog gain register maximum value. So we remember that its value was 900. If we think that it should not be that low, should be 990. We can change that. Oops, we can change it to that value and save the file. And then we can use the CCS Static Data YAML to binary converter to convert the file into binary. We use the S option, which is for the sensor, and output is directed to, let's put it under TMP, sensor.fw, and then the input file. Okay, there was a warning, but that's okay. If we want, let's see what we got out, not on dev, but TMP and file, just less than 2 kilobytes. That this is actually now the file that the sensor driver should be loading next. So we need to make it available for the sensor driver. So this describes the same data that we just saw in the YAML file, including the change in analog gain code maximum value. So now I need to become root user. Then I'm going to copy this file to where the CCS Static Data binary that will be loaded by the sensor driver is. So it's going to be lib firmware. These paths are somewhat specific to their operating systems. Well, Linux-based systems mostly use lib firmware, but it can be something else as well. And they're under CCS. And we already have one file in the directory, which is called CCS sensor. For the purpose of the demo, I've been using all zeros in here. But normally you would have this first value would be vendor ID, the next one would be model ID, and the last one would be version. So we'll copy it there. And then I will need to reload the driver. This is required at least at the moment. So everything seems fine. Now we can go again and see where we are and check. Device is still the same sensors pixel array subdevice, and it seems to have the same number. Let's see what is the value there when I check the controls. Analog gain. There it is. The maximum value is now 990. If you compare this to what we had with CCS 1.0, first of all, we didn't make a hardware change, and secondly, we also didn't make a software change. We simply made a change in the CCS static data. And I think that this is a significant improvement from the past. This driver, by the way, is already in the Linux mainline kernel. Not all the features are in, but it is there, or at least will be. It's not yet in a release. Thank you.
Thank you very much, Sakari. Appreciate that presentation and also appreciate your demonstration. So with that, we will move forward into our Q&A session. And again, I encourage you to enter your questions into the Q&A pane, and we'll take it away from there. Thank you.
So hello everyone, I'm Ian Smith from MIPI Alliance, and I'll be moderating this Q&A session with Sakari. Realized that during the presentation, the slide deck wasn't advancing correctly, so apologies for that. You can download the slide deck. There's a resources box, and you can download a PDF of the slide deck from the link within that box. So if you want to take a look at Sakari's slide deck, please do that.